We start with a nested node class. Each node holds a map from a character to its child node, and a Boolean isEnd of word that marks the end of a valid word. The tree class has a single root node, initialized in the constructor. This root represents the empty string prefix. Insert walks through each character of the word. If the character is missing from the current node's children, a new node is created. At the end, the final node's isEnd of word is set to true. This builds the tree structure. Common prefixes share nodes, saving space. Search and starts with both use the helper find node, which traverses the tree along the given string. If the traversal ends at a node, starts with returns true, search additionally checks isEnd of word to confirm an exact match. Delete is a recursive method. The base case reaches the end of the word. If it's a word, we unset isEnd of word and return whether the node can be removed, i.e., it has no children. The recursive step proceeds to the next character. If the child doesn't exist, the word isn't present. After the recursive call, if the child node was deletable, it had no children and was not an end of word after removal, we remove the child link from the current node's map. Then we tell the parent whether the current node itself can now be removed, if it has no children and isn't the end of another word. This ensures we never leave dangling empty nodes. Autocomplete first locates the node for the given prefix using find node. If it exists, it calls collect words, a DFS that accumulates words up to max results. It uses a string builder for efficient prefix building, appending each child's character before recursion and deleting it after, backtracking. This gathers all words starting with that prefix. We create a tree and insert a set of words that share prefixes. This builds a tree where CA leads to T, R, RD, RE, and D branches to other words. The printed results will show the structure in action. The output confirms exact searches, prefix existence, and autocomplete results. Deleting car removes that exact word but keeps card and care intact. The autocomplete for CA no longer includes car. You've built a tree from scratch, the engine behind real-world autocomplete and spell checking. Understanding tries gives you a powerful tool for prefix-based queries and efficient word storage. This data structure appears in interview questions and system design. Now you can implement it confidently.